So to get started, let's take a look at our question for today. The question I'm posing to y'all as a question is, what do you think is a realistic timeline for the first humans to travel to the closest solar star system other than our own? So basically, when do you think we will go beyond our solar system? I think honestly, this question is instead of a, this question is less of a science question and more of a psychology test. Really, it's basically a measure of how optimistic of a person you are. I think that's what it is. To be TBH, I think that's what this question is. It's not really measuring what do you like. Oh, it's measuring how optimistic of a person you are. I think it's really interesting. We got 11 out of 13 people. We have a lot of interesting responses so far. So we'll take a few more minutes as people roll on in. So what do you think is a realistic timeline for the first human to travel to the closest solar system other than our own? Once you submit the warm-up question, you should open up your graphic organizers from the last period, which we will continue working on because we will continue talking about rockets and space travel. So once you finish the warm-up question, go find your graphic organizer and open that up. For those of you just joining us, I want you to answer the warm-up question. What do you think is a realistic timeline for the first human to travel to the closest solar system other than our own? When are we going to go Star Wars style and have a hyperdrive and go colonize other planets? I also really like seeing the distributions of answers across classes. It tells me which classes are more optimistic than other classes. Yeah, optimistic, pessimistic, or realistic. Yeah, that's basically what it is. Um, so yeah, so it's interesting. I think, it'll take a couple more minutes for those people joining us. So for those who are just joining us, please answer the one question. What do you think is a realistic timeline for the first humans to travel to the closest solar system other than our own? Once you answer the one question, go open up your graphic organizers that we were working on last class, and we will continue looking at rockets and space travel today. For those of you, we actually are at 21 out of 23 so far. That's actually really good. So thank you for those of you who have responded. If you haven't responded yet, please do so and open up your graphic organizer. Take another minute or two for people to answer the warm up. Yeah, yeah. Honestly, TBH, I don't really know what the answer to this question is. I really don't know what the answer to this question is. I mean, there is no correct answer, obviously, because we either predict the future. I mean, I can predict the future because I'm just like I'm just crazy, crazy, smart, whatever. But this question is really interesting. I honestly can't really think of an answer for this. Um, it's hard to envision how much our technology will progress in in the coming years. But yeah, let's take another. How much more time do we want to take? 10 more seconds for those of you. We just need one more person to answer the warm up. We're at 23 out of 24. You might just wait. Uh-huh. I don't think so because we're at the stage where artificial intelligence is getting ridiculously smart. So so this is something called Moore's law. Moore's law is basically says that it's like not really a law, but it's more of a pattern. It's basically saying that the amount of computing power that is available to our species, humans, doubles every, I think like two or I don't know, it doubles every amount of years. So basically just saying the amount of computing power we're having is just constantly doubling and doubling and doubling. So I don't think there's a limit to how much our technology will progress because at some point we will produce like extremely, I mean, our artificial intelligence right now is already very, very intelligent. Like, self-driving cars are pretty like smart. The fact that, your the targeted ads that you face are also pretty smart. So our artificial intelligence is already pretty smart, and it will only get smarter. That being said, we are limited a lot by the physics of reality. So I think that's probably honestly the biggest barrier. I think is overcoming the limits of physics. In terms of computing, I don't think there is a limit. Well, there actually is a limit to this starts getting very complicated very quickly. Basically, there's a lot of limits to reality, and one of those limits is quantum mechanics, and that is starting to become a big factor in computing as well. If you ever want to know more of that, you should ask me, and I can try to give you my best explanation of it. But that can be a very long-winded, and I'm already starting to get off track. Okay, so let's take a look at what people say. So we have 23 people who responded. About a third of the class has said never. About a fourth, a fifth of the class said by 2200. 7 people said 2100. 4 people said 2050. So fairly even with a lot of nevers, which I think is actually really interesting. It's very, very difficult to travel to the nearest solar system. So I think never is a pretty, I think it's fairly realistic, but I'm an optimist, so I would say, I personally, I would like to see us travel to the nearest solar system. So I personally would like to see an answer. I personally would like us to eventually travel to the nearest solar system, but I think never is a very realistic answer. We will see why. So thank you for those of you who responded. So what we're going to do today is we are going to keep talking about rocket science. I want you to open up your rocket science graphic organizers and then finish those up. I think I said do it in a class, but during fifth period, there's a couple of things we didn't quite cover. So I don't think we'll quite finish everything today. We'll try, we'll see. But I don't think we'll get there. So make sure you open up your graphic organizers because we will continue working on that. And right after this, we will start with a discussion on rockets themselves. So there is an update I have. So the previous assignment, the most recent assignment we're working on is called position versus velocity graphs. I actually made a fairly big mistake on it. The last graph on it, the blue, which is the blue velocity graph with numbered velocities on it, that should be skipped. That's because we haven't really learned a lot of the ideas behind it. So I don't really expect you to be able to do it. So I deleted it from the assignment. So make sure you please skip it when you get through it. So I made an announcement on this on Canvas. So basically the last blue graph on the position versus velocity graphs assignment, that is not doable. So I can definitely skip it. It's totally okay. Well, you should skip it, especially if you don't know how to do it. So please do skip it. It was a big mistake on my part. Forgot to take it out. So if that was the main detractor from you doing it, hopefully that is no longer a case. Okay. So, but just let me know if there's anything else that's an issue, and I'll always fix it. So that's the update I have for that assignment. Does anyone have any questions about that? Okay, so alrighty. So here's what I do today. So the first thing we're going to do is we're going to talk a little bit about how rockets work. So currently, the main way NASA and other space agencies, well, not the main way, the only way we send stuff into space is through the usage of rockets. There are some other technologies that are being investigated, but rockets are not the main way, the only way that we currently send stuff into space. So what I want you in your groups, I want you to discuss how you think rockets work. Now, I know this can be kind of tricky. A lot of people are like, I don't really know how rockets work. I want you to give me your best idea, your best hypothesis. How do you think rockets could work? What do you think are the main ideas behind it? I'm not looking for a correct answer. I'm looking for ideas. That's really what matters in science. They like coming up with hypotheses. So I want every group to try to come up with some ideas that on what you think, or at least you can try to say as much as you know about rockets. That could also be interesting. So I want you to discuss how you think groups work, rockets work. There's a space for that. I believe it's box I think, in the graphic organizer. So I believe that you can fill out blocks I. So in box I, try to just fill out what your group discussed. And then when we come back here, I want you and your group to be prepared to just write out a very quick summary of what you said in the Zoom chat, waterfall style. So that's the plan. So we'll take, I don't know, 5 to 10 minutes to discuss how we think rockets work, and then we will come back and do that. Okay, so in the next minute or so, what I want you guys to do is I want you guys to type out what your group discussed. Am I muted? No, I'm not muted. Okay, so I want you guys to, in the next minute or so, I want you guys to group you and your group to type out what you guys discussed on how you think rockets work. And so I'll tell you to hit enter in about a minute and a half or so. So just quickly write out what you and your group discussed in terms of how you guys think rockets work, and then let's see if we get some ideas from the audience. So yeah, take a minute and a half or so till 10:31. Write out what you and your group discussed in terms of rockets. Rockets are sick AF, sick AF. So how do you and your group think rockets work? What ideas did you guys come up with? What do you know about rockets? What do you think are important factors in how they work? Okay, so in about 5 seconds or so, I want you to hit enter. 3, 2, 1, hit enter. What did you and your group discuss? What did you guys say? How do you think rockets work? Let's get some answers in the chat. Got one so far. I was in a couple. I was in a few groups. I heard some ideas here. Let's get them in the chat. Okay, there we go. There we go. They're popping. They're popping. Here we go. Got a lot of answers in the chat. If you're still writing, take some time, write it out, hit enter. I've got a bunch so far. So I'm gonna start reading through them. So the rocket engine pushes backwards, which makes the rocket go forward. Wow, that's good. That's really good. Exactly. Honestly, we will do some reading on that. But yeah, um, rocket engine pushes back, which makes the rocket go forward. Exactly. Liquid fuel in a funnel. So Miles actually had a really good explanation for how rockets work. Uh, I don't know if Miles, if you want to share it with the class, but it was really good. It's up to you, but it was really good.
Sure.
Um,
So, the theory that I did was, uh, rockets, or at least rockets now, are two tanks or more of liquid fuel that come together in like a little antechamber with a funnel on the bottom, uh, to and the fuel oxidizes or has a spark and burns and basically explodes in the little antechamber, pushing the rocket upward because it only has one exit to get all of that excess energy out of, so it pushes it out of brute force of explosives.
um, yeah. So Miles, you just took my job. Honestly, that was really good. Honestly, yes, that's exactly. I couldn't have said it any better myself. So, yeah, Miles, that was really good. So yeah, basically you have multiple tanks of fuel and they're mixing together, and then they're basically blowing up. So Miles, great job. Thank you very much for sharing. Very cool. So I'm just going to read through other people's ideas. The rocket uses some type of fuel that is powerful enough to push at a very high speed. Yes. They work with a lot of power and a trial and error. Ooh, I don't think people realize how much trial and error was used to build rockets. There was a lot of trial and error, which is honestly huge for our science, trial and error. Slow release of fuel energy in a small container to move the rocket forward. Basically, strapping yourself to a missile, but with food, a lab, and a place to sleep. Yeah. Honestly, a lot of times there's not even a space for a lab, TBH. Sleep is also kind of overrated in rockets. Food, kind of overrated. But yeah, you're basically strapping yourself to a missile. Um, it's like firework. They propel into the air by using gunpowder, but for the rocket, they would use fuel. Wow. These are some great explanations. I really like. So you guys are. I see a lot of future budding rocket scientists. I may or may not be recruiting rocket scientists in the future to send me to Mars. So thank you all for sharing. So what we're going to do now is we are going to take a look at, actually we're going to do is we're actually going to read an article on rockets. So right here, what I have is I have a link to an article on rockets. I have a link to an article on rockets, and we are what I want you to do is I want you to go through the article, and I want you to try to create an explanation for how rockets work based on what you learned from the article. This is very important for the scientific reading. Is you do a lot of reading in classes and stuff, and it's important to be able to read an article and digest the information. So what I want you to do is I want you to open the link to the article right now, and then I want you to start reading through it. What I think I will do first is I will first. So I'm going to give you a couple minutes to go through the article, just start skimming through it, and then I'm going to show you my thought process for how I read an article and how I identify the pieces of information to look at. So then I'm going to do that, and then I'm going to put you in your groups, and you guys can discuss portions of the article in terms of what you guys learned from that. So yeah, so give me 5 minutes, open up the article itself, and then we will read through it again, and then I will sort of show you my thought process here. Yes, I will put in the chat. Explainthatstuff.com. So just open up the article, just quickly skim through it. By skim through, I mean just scroll down at the very end like I'm doing. Okay, and then I'll start showing you my thought process for how I read an article here, how I pick out pieces of information. Then what I want you to do is I want you to go into the article with your group and then try to come up with an explanation for how rockets work yourself. So okay, so the first thing we need to do is we need to take a look at this section called how space rockets. Okay, so this is the introduction. And if you look through it, it seems like it's very exciting. There's exclamation marks. There's a little bit of history about 13th century China. Shout out to my Chinese people. A little bit of history here, but for the most part, none of this really tells us how rockets work. It even says how exactly do they work. So if I'm reading this article and I'm trying to find information, I'm just going to skip this section. Okay, so to give you a preview of what I'm doing, so a lot of times what you do is you read articles in science and math, in any subject, and your teacher, including me, may give you an article and say like, okay, read the whole thing, tell me what you learned from it. So what I'm going to tell you is I'm going to tell you something. You can read the whole thing, and I'm not saying you shouldn't. You definitely, ideally you should, and you should get knowledge from the whole thing. But if you're like me, and especially if your time is an issue, and especially once you start getting to more and more nastier things, you sometimes don't really have the ability or the time to read the whole thing. So this is what we call picking the pieces of reading the article and trying to figure out what is important. So this is a very important skill in this class and any other class, reading this whole thing and just trying to quickly identify what pieces of information are important. So I'm showing you my thought process here. How do I pick out pieces of information that are important? So right now I just read the introductions. Usually the introduction is very useful. So it gives you basically what the article is about. But if you quickly read this article, this section here, you realize that it just tells you something. It's like a whoa, space is cool kind of thing, but it's not really helpful. So I've skipped that. What exactly is space? Well, this tells us about space and not rockets, so I'm just going to skip this too. Bam. We already went to the first page and we didn't read any of it, but if you actually read it, you would realize that it's actually not super helpful. So I just saved a bunch of time by not reading a couple of sections. Where does space start? Is this super helpful for us? I'm going to say no. Again, we want to figure out how rockets work. Even though this is some cool context here, it tells us a little bit about space. If we're trying to get straight to the point, we want to know about rockets. So what is space like? Again, could be helpful, but I'm trying to get to the meat here, right? Get to the if you're vegetarian, get to the tofu. That's what we're trying to do. So is there more than one kind of space? Very cool, not really interesting and for our purposes. So we're just going to skip that too. Bam, we just skipped through another page. We didn't read any of it, but we don't have to read any of it. Okay, so now this is when we don't want to skip things. Why do we not want to skip things? Because the title says, "How do rockets work?" So if we're trying to read an article and trying to figure out how do rockets work, we want to read the section that says, "How do rockets work?" So we do want to read this. Now I'm not going to read it right now because I'm going to let you guys read it, because that's the point of this, is to you guys read it and get information. But I just want you to know that that's how I realize, okay, this is a section that I need to know. So you guys should definitely read this section as well. But I'm going to just go through the rest of the article here, and I'm going to start showing you which sections you might want to skip as well. Okay, so that's a good section. This section's a little bit more technical, but I think it's kind of interesting as well. It talks a little about thrust and drag, which are important physics concepts for how rockets work. You can also learn a little bit about escape velocity. So this stuff right here, this is more technical, and because it's technical, it is kind of helpful. It's not the most important part of the article, I think, but this is one of those things where if you have time, it's not bad to read as well to give you a little bit more context. But this is sort of more skippable. So this is the part when you realize this and you start reading it, it gets very technical. When it gets very technical, it's we're trying to get a big picture of how rockets work. This is not the most important part. Then when it goes to the rest here, and then this talks about parts. So this is when it gets really technical. Parts of a space rocket. This is when it gets really technical, and this is when you definitely can start skimming through this. It's not very helpful. And then this talks about rocket engines. Rocket engines are actually kind of useful, I think. Interesting about if we want to know how rockets work, I think it'd be helpful to know about rocket engines. So I think this could definitely be an interesting thing to read. So definitely you could definitely read that. But then this last part here, when it starts talking about a typical space rocket, I think you can skip this. Right? It's a typical rocket. We don't care about a typical rocket. We want to know how rockets generally work. So from this whole article, which is kind of long, we pretty much identified which parts we should read. So that's sort of an idea of what your strategy should be when you're looking through a scientific article. What parts are important? What parts can I skip? That's gonna be a skill that you'll have to you have to develop. But for now, I sort of did it for you, sort of help you identify which sections you want to read. So I'm going to put you in your groups now, and then when during your groups, I want you to read through the article and try to piece together an explanation for how you think rockets work based on the knowledge you read. So I'm going to put you in your groups now, and then when we come back, I want you to have an explanation written down for how rockets work based on this little bit of reading. Thank you for all of those who I got to see talk a little bit about how rockets work. So thank you all for sharing. I learned some really interesting stuff from you guys as well. I think in general, I think the general ideas here that we want to sort of focus on is that okay, so in order for rockets to work, you basically have to burn fuel. When you burn fuel, it basically pushes all the gas down, and then when you create a lot of force pushing you down, ironically, that also creates a lot of force pushing you up, and that's what produces the thrust, which is basically the word meaning that the amount of force that's pushing a rocket upwards. It produces a lot of thrust that pushes your rocket upwards. So that's just the main idea of it. There's still some more technical stuff that if you got to read a little bit more, you got to learn a bit more about. But that's sort of the very quick, in summary, definition, well, not definition, but explanation of how rockets work. So I hope we learned a little about something about that. We will talk a little bit more. We will continue talking about more about rockets in a second. But as we talk about, but instead of talking about rockets for now, we are going to shift from rockets to car mile per gallon calculations. Now, here's the thing. Car mile per gallon calculation. So if your parents have bought a car at some point in their lives, they may have researched or seen something about the car mile per gallon estimates. So if you've ever, I'm telling you, if you've ever watched TV or an ad or something, they'll say something like, this car gets an EPA estimated like 38 miles per gallon or something. So those are estimates on how much miles a car can drive per gallon of fuel it has. The thing about what they don't tell you is that about these ads, they don't tell you is that a lot of times these calculations are very inaccurate. And that's because car manufacturers, they will sometimes test the fuel efficiency of a car with no passengers and with many of the seats taken out of the car as well. So what I want you in your group is I want you to discuss, why do you think doing these things would affect the fuel efficiency of the car? Why would taking the seats out and removing the passengers affect the fuel efficiency? How does this affect the fuel efficiency? Why does this matter? So I want you to take a couple of minutes here with your group, come up with some ideas for how taking the passengers out and taking the seats out would affect the fuel efficiency, and why would it affect the fuel efficiency of the car? So yeah. So the general idea that you and your group may or may not have come up with is something like this. You might have something like, if I take out the passengers and I take out the seats, you may have said something like, my car is now going to weigh less, which makes it easier for the car to move. And if you think about it this way, right? Imagine you're going to school one day and you have to return all of your textbooks. So your backpack is really, really, really heavy. So you're using a lot of energy to move the same distance, right? Just move some distance. And now the moment you take all your textbooks out and you return them, you can go that same distance, but you don't have to use as much energy, right? You have to use a lot more energy to travel the same distance if you weigh a lot more. And whereas if you um, but you don't have to use as much energy if you don't weigh as much, right? So it's ideas of so when I say fuel efficiency, in many ways it's energy efficiency, right? It's more energy efficient to carry less weight than it is to carry more weight. Okay, so Mr. Hu, this is about cars. So how does this relate to rockets? So this is where I want you to think about this. So I'm calling this the catch-22 of rockets. So let's assume that you're in a car and you're trying to make a road trip from your home to New York. You're driving across the country from home to New York. What I want you to think about is this. If you're trying to make the trip in one go, so which means that you're not stopping, it's nonstop, you're not stopping at gas stations, you're not stopping for layovers, not stopping for anything, you need enough fuel to make the trip in one go, right? So you're loading your car with a ton of fuel, trying to make the trip from the beginning to the end. So, and you need enough fuel to make the trip in one go, right? So using this idea of a fuel efficiency, the idea we just talked about, and I want you to use the idea of, the fuel efficiency, and I want you to relate it to the mass of the car. What issue do you run into as you continue adding more fuel to your car? So you're trying to make this trip in one go, and so you need to add a lot of fuel. So as you continue fueling your car, what issue do you run into? And I want you to use the idea of fuel efficiency, and I want you to relate this to the idea of the massive car. And I want you to see if you can come up with some ideas for what happens if you continue adding more fuel to your car. Um, Okay, so I talked with a couple groups here, and let's see if we can discuss this issue here as a class. So what issue do I run into as adding more fuel to my? Okay, so my car, I'm trying to make a trip from my home to New York. I need a lot of fuel. So I load my car with a lot of fuel. The problem is though, as I continue adding more fuel to my car, what happens to my car? Well, guess what? It gets a lot heavier. Its mass increased a lot. So what happens if my mass of my car increases a lot? The fuel efficiency gets a lot worse, which means I need a lot more fuel. So what do I need to do in order to make sure my car can make the trip? I need to add more fuel. But what happens if I add more fuel to my car? It gets less fuel efficient. How do I accommodate that? I need to add more fuel. What happens if I add more fuel? My car gets more massive and it's less fuel efficient, which means I need to add more fuel. So this is vicious. So as you can tell right here, we're in a bit of a pattern here, right? It's a vicious cycle. If my car is too heavy mass in the beginning, I need to add a lot of fuel, which means my car it's going to be less fuel efficient, which means I'm going to need more fuel. And it's just this vicious cycle, vicious cycle. So that's the main issue we're running into, right? The problem is the more fuel you carry, the more fuel you need to carry that fuel. And that is honestly a huge branch of, or honestly, I would argue that the singular most important thing that all engineers and scientists and stuff need to consider with rockets and sending stuff to Mars is weight. Because if things are too heavy, the heavier something is, the more fuel you need to send it there. And the more fuel you need, the more fuel you need. So if you can keep things lightweight in the beginning, right, you don't need to worry about this problem. But if things get too heavy, things can balloon out of control very quickly. So if you ever watch the rocket launch or something, what they do is they use like, if you ever watch the space shuttle, what happens is they have the main space shuttle. It's attached to this main booster tank, this main fuel tank, and it has two secondary boosters, right? So when the boosters are basically like, you can think of this, they're like external gas tanks essentially, right? They use up all their gas, they use up all their fuel. Once they use up all their fuel, right, you don't want to carry it anymore because that's just extra weight. So that's why that's why they break off. And then so when the booster uses its first two boosters, it drops off those boosters, then adds the main booster, it drops that booster, and then it's just the space shuttle with its fuel left. So basically that's probably the main thing that you need to consider when you're sending stuff to Mars is the weight of the object itself. Okay, so I'm gonna talk about one more thing about I'm going to talk about one more quick idea here before I'm going to skip this. We're going to come back to that. I'm going to talk about this. I think we'll probably pick this up on Tuesday, but I'm trying to talk about it as much as I can. So stop lagging. So have any of you ever heard of the term lag? You probably have, and you probably use it in your daily language, even if you're not a gamer. If you know what lag is, you know how infuriating it is. What is lag? Lag is used to refer to the delay between an action and a reaction. So if you're a video gamer, we use the word ping to measure how much delay this is, right? And this is the delay between my input and when the character is doing action. So let's say hypothetically, right? So for example, what is so if you know what ping is, right? They're usually measured in milliseconds. So let's say hypothetically that I have a ping of 36 milliseconds. What that means is that if there's money on the floor and I'm a person playing a character, right? When I click pick up the money, there is a 36 millisecond delay between when I click pick up the money and when my character picks up the money, right? Why is there this delay? Because this ping is literally a measurement of how long it takes light from travel that distance and back. So this is because all communications are done by sending light waves to and from locations. So when I click my mouse, it's sending a light wave to the website or game or whatever, which then sends a light wave back to my computer, confirming that I did it and click my mouse. And the measurement of this time that it takes is called ping. And this is a huge issue we will see in next Tuesday. This is a huge issue with sending stuff to Mars, is how much ping it has. Okay, so that is it for today. Hopefully you guys learned something new. We will continue talking about space and stuff on Tuesday. But other than that, that should be it for today. It's 11:19, so I will wrap up here. In terms of assignments, you guys don't have any homework. I'm just going to remind you that I made a mistake with the position and velocity graphs. So don't do the last problem, the one with the big blue velocity graph that has a lot of numbers. You can skip that because I made a mistake with that. Other than that, you have no homework, and we will continue talking about this on Tuesday. So you guys are free to go, and I'll see you guys on Tuesday.
Thank you.
Bye. Thank you.
You-
Thank you.
Bye.
Bye. Bye-bye. Oh.